We're here today to go deep on the Windows shell.
The Windows shell.
We're here with a couple of architects from the Windows shell team. So why don't we start off, maybe introduce yourselves, give us a little bit of background.
Yeah, so I'm Chris Guzak. I've worked on the Windows shell for probably 15 years.
Mm-hmm.
I started off 88, worked on Windows 3.0, and you worked on Windows 95, right?
I started in Windows 95.
Yeah. So I've been working on the shell for a long time. Worked on Windows 3.0, Windows 95, Internet Explorer, version 3 and 4 and 5, I guess, which was partly shell integration.
Mm-hmm.
Shell integration was one of the goals of that release. So
you've seen it all,
yeah,
pretty much, the whole history of the evolution of the shell.
Yeah, been working on it for a while.
Chris has seen everything. My name is Mike Sheldon. I've been at Microsoft since '92 and been on the shell team since about '93. So certain aspects of the shell architecture were in place, and I got to keep working on it from then on through the IE integration up to today.
So what would you say? What is the shell? I mean, if you had to say, how would you define the shell?
That's a good question.
It is the soul of Vista.
Soul of Windows Vista. I've heard that said. Yes.
I think the kernel team might disagree.
It's for the user experience soul. It is what users deal with. It's their startup experience. It's what they see when they first get on there. It's responsible for a lot of the end user.
Yeah, it's the end user facing part of Windows. It's the components that users interact with directly. It's the Explorer window, it's the desktop, it's the taskbar, it's the tray, and the control panels, and lots of there's lots of framework and kind of application level code in the Explorer.
Does it all run in Explorer.exe, or are there lots of DLLs that go into it, or is that your?
The shell itself is made up of components, things like the file open dialog, things like that, and those components often run in other applications. So the file open dialog is a classic example of an instance of the shell that runs in other apps. So
because it's interesting, if you go to the task manager and you kill Explorer.exe, it regenerates itself. There's some, not that you're recommending that anybody would do this.
Well, the system has special support for restarting the Explorer, and actually Vista adds a new API for other that lets applications essentially get the same functionality. And it's this idea of the restart manager lets you register your application for restart, automatic restart.
Excellent.
And the actual aspect about Explorer restarting is the service of the logon service. And it actually restarts the registered shell program.
Mm-hmm.
So there are some installations where people use something other than Explorer. You can actually have that restart as well.
Yeah.
So it's just a generic feature.
So, but I mean, what is Explorer.exe? I mean, I guess that's
Explorer.exe, that's a good question. So Explorer.exe, the very first one that launches is your desktop. It's the icons you see on your desktop. It's the tray that lets you interact with your applications, and it's the start menu. Cool. And I'll recap something Chris actually just wrote in kind of a brief history of Explorer process. In Windows 95, it was just one process with one thread per window and one thread for the desktop start menu and the tray. And then in NT4,
yeah.
NT4,
separate process.
Separate process was added for robustness. So then you had the desktop process and then one process for all the other windows. And there's a UI switch for that today. And a few people turn it on. A few corporations do it by policy. And we may actually switch around to run that way by default in the future.
That's right. Threading's a complicated issue in the shell. I mean, what do you do to resolve all of the different, you have your message loops and all the different extensibility modules that third parties provide. What are the main challenges about, how do you keep that working? And
well, it's kind of a general question.
Kind of a vague question.
Yeah. So the Explorer, like I said, the Explorer runs each Explorer window on its own thread, and the reason we do that is to achieve isolation of the execution of each of those windows. So one of them might have a message box up that's prompting you to answer some question, and the other ones are still interactive and aren't blocked. And also, if there's a hang on one Explorer window, we don't want to block other ones. So that's was kind of a basic decision that was made. We did the initial architecture of the shell, and it remains today. And it's still a reasonable strategy. Many applications, of course, some applications follow the same strategy. Internet Explorer does the same thing. But some applications don't. Like you'll notice Office, Word, for example, they run all their top-level windows on the same thread, which even reveals itself as sometimes in terms of hangs that happen in one instance of Word affect the other ones. So.
Is there some type of, if you go into Windows programming where typically the UI elements are bound, they have affinity to the thread that they were created on. What are some of the reason? What is the reason behind that? How is that built into the architectural? How did that decision? Was it something that was specifically explicit decision that was made?
Well, it's not that issue is a window manager issue mostly. That is one of the basic the window manager, the model that it implemented for Windows has Windows being associated with a thread, and that's something it's a given if you're using Windows as a basic primitive of creating an application, which most Windows applications do. Mm-hmm. So that's not really a decision that we made. It was made really, I guess, Windows 1, Windows 2 timeframe. I guess.
Although we did embrace that decision when moving over to COM. Mm-hmm. So in COM world, you have the option of the single-threaded department or the multi-threaded department, and Explorer is an STA application, pretty much to align with the fact that we're Windows-based, which is one thread for your UI, and by making that STA, it made our programming model much easier. Mm-hmm. And our extensibility model follows the same thing since it was developed back in Windows 95 timeframe. So that follows the STA model.
That's good. That's interesting. So why is there a possibility that we move beyond the STA model? Because you mentioned it was what Windows gives you, right? Not a decision that the shell team made. I mean, it's just an architectural decision of Windows.
It's a good decision for various aspects for our UI.
Okay.
The STA model of COM matches a UI model where you're bound to HWind-based elements, since they're both thread-bound.
And there's quite a few facilities that are built in the system that kind of assume this send message and the way input's processed is all kind of bound up in that same model. So there's definitely some downsides to the STA model, but there's also a number of advantages. It also promotes a kind of easier model of programming. You don't have to worry about synchronization and things like that because the window manager effectively does it for you. Mm-hmm. You'll notice if you look at the implementation of Win32 controls or Win32 window class, you'll hardly ever see any explicit serialization of critical sections or things like that. That's because all the processing is done on the input of messages. Mm-hmm. You're guaranteed to be serialized when you're handling those messages.
I'm just making an excellent comment. Sorry.
No, so Mike, you mentioned extensibility. So what type of extensibility hooks does the shell provide for developers to integrate with the shell?
Too many. Quite a few. In fact, the topic of accessibility is one that we're always engaged in. There's all sorts of difficulties that come from it, design issues, what's the best way, what's the best pattern to use for extensibility? How do you manage the downsides of fragility that come from extensibility? How do you provide just enough power at the extension point, but making it general enough to satisfy other scenarios that maybe didn't anticipate, things like that. So it's a vast topic.
And it's a topic that's changed goals and priorities over the last 15 plus years. So a lot of Explorer's extensibility was defined back in Windows 95. So a lot of the core APIs are there and have a lot of behavioral app capacity requirements now. And the goals today are very different. We have machines that are much faster, and you could pursue process isolation, extensibility points, and actually build a robust system that way. But it's very hard to change an existing platform. So one of the things you'll see us doing right now is some of our new extensibility points will be following newer, more robust models. As we trying to figure out how to take our older stuff and move towards that model, but I wouldn't expect anything like that in the super near future.
Yeah, well, for Vista, we're doing...
For Vista, we're doing some new ones.
Yeah,
Some new
so
ones
we're isolating, we're running our preview handlers. So we've got a new extensibility point, preview handlers, which are objects that know how to render a preview for a certain file type. So you select an RTF document or a PowerPoint or a JPEG or whatever, and we can host a preview control that can have some interactivity with the user and let you flip through pages and examine the thing in more detail. And that model is implemented out of proc. We're getting a couple benefits from that. Of course, there's challenges that come with that as well, because the performance, there are issues you're going to relative to performance, managing multiple processes, and trying to keep them alive, especially because essentially a lot of the implementations, these will be the full-fledged applications. Office applications themselves are started to implement the preview handlers. It's an example of their implementation.
So is that a new API for people to plug into? For example, you mentioned it's a PDF document, and it's an instance of Acrobat, like they have some ActiveX control they register, or?
Yeah, well, it's not an ActiveX control. It's a preview handler, which implements a hosting mechanism very similar to ActiveX. In fact, it's probably
a little
simpler than ActiveX. And the cool thing about this extensibility point is the design here is shared with Office. So the new next version of Outlook is going to have the same capability built in Outlook, so you can use these same handlers to preview your documents in your inbox.
Excellent.
Which would be pretty cool. So just kind of got some collaboration there. This one's actually reasonably well covered. I think the PDC material, we had samples and a talk that covered that. So it's pretty good. But back to your general question, extensibility is everywhere in the shell. In fact, you can kind of think of the Explorer as its base functionality is a host for extensions. The views that you see in the Explorer are extensions, and as you navigate around every page that you see in the Explorer is provided by some extension.
So, for example, like control panel looks like it's part of the file system when you're viewing there.
Yeah, correct.
Could I do that if I'm for my own stuff, for my own application? Can I integrate my own items into the shell like that?
Yeah. So
the control panel is an interesting one because it's not actually the file system. It's a different view. And so internally, let's back up a little bit. Internally, as you're browsing through the system, you see this hierarchical view of things that look like folders, file systems. Each of those is a data source provider for that area of our overall namespace you're browsing through. And the control panel is not a file system based one. It's built with some custom code that actually does look at the file system for .cpl files. Also looks in the registry for registered control panels. And so that one is a different data source implementation than your generic file folder.
But could I write my own data source for something that wasn't file-based that I could plug in that way?
Definitely. And you see lots of examples of this. Well, Windows itself is composed of a bunch of different separate data source implementations. I think there's, last time I looked, there was like 25 different data source implementations across the Windows code. Office provides a data source implementation in the form of their web folders feature, which they've done for a long time. Well, that's kind of superseded by built-in support at the file system level. Applications, I've seen data source implementations for Gmail. There's a shell data source that lets you get to your Gmail storage. It's something you can download. The handling for zip folders is kind of a classic data source implementation because we expose the items in a zip file or a cat file through the shell program model.
Very cool.
Would you say how many different types of, rough estimate, would you say of different types of extensibility points are in the shell? Is it tens, dozens?
Probably dozens.
Well, it depends on how you define extensibility points. Someone actually went and collected a document covering all the extensibility points in Windows, I think it was, but they took an end user perceived definition of extensibility point. I think came up with 500. So there are 500 things that have some sort of customizability and control that feel like extension points to end users.
Is there some place that I could open up and get a view of what I have defined for all of those points or some subset of those points?
There are some tools that have been written. I think Raymond wrote a tool.
Raymond Chen?
Raymond Chen, the famous Raymond
The
Chen.
famous Raymond Chen. Who won't come on Channel 9.
Yeah,
Can you believe that?
You won't?
Yeah, but I'm sorry.
Really? You must be
Yeah.
afraid of the camera.
You think he is? Nerve-wracking, isn't it?
Yeah. So we don't have. So this is actually not, it's unfortunate. We do not have a single place in our UI to let end users or administrators manage our extensibility points. We do have some tools, things that we've written and some are available. Actually, I'm not sure how broadly, but this is actually something we'd like to do more of in the future. So Internet Explorer has an extensibility management UI, which interestingly is built on top of the Shell data source abstraction. But we hope to kind of grow that, or we hope to grow that type of experience in the future, so that it can cover extensibility points that the Explorer and the rest of Windows has. Actually, there is some support in the anti-spyware, the Windows Defender part of Vista for managing some extensibility points. I'm not super familiar with it, but I know they do have some. That was actually one of the reasons we didn't go much further with that implementation that we had there.
And are all those extensibility points implementations of COM interfaces? Are they registry what do they look like?
So we prefer data-driven extensibility. That's always the best solution. It's easier for people to implement. You have to write code. It's safer for us because we can change the implementation, and we don't have to worry about robustness issues of executing third-party code. So we always start with, whenever we're talking about extensibility or adding an extensibility point, is can we satisfy the requirements with a data-driven law? And if you can, that's always preferred. But there's plenty of code extensibility points as well. So an example of a data-driven one is you can change the icon for a certain file type by adding an entry in the registry that maps the file extension to the icon that should be displayed. Kind of classic trivial example. But you also can write an icon handler that will compute the icon for a file, possibly based on its contents at runtime. So that's a reasonably common case that you see.
So I guess it depends. Would it be fair to say that the more simpler ones are the data-driven? You have to put the data into the registry typically, or
Yeah.
and then the other one would be COM interfaces that.
Yeah. So
implement?
So COM is kind of the basis of that's the basis of all of our extensibility models. There remain some get load library, get proc address extensibility points that exist basically due to the legacy. Control panel is one example of those. CPL files are just DLLs with a well-known entry point. There are others, of course, but generally we're going to do a new extensibility point. COM is the way to go.
And so for those who have said COM is dead, would you say that it seems with all of the new COM APIs of Windows Vista that what would you?
Yeah, COM is super important for us, and I think a lot of apps that native code. Classic Windows applications. It's kind of applications, or COM kind of raced ahead in terms of capability. It had lots of interesting functionality that we didn't utilize, certainly. For example, out of proc activation is something that we only started doing. Well, we only have a few new extensibility points that support that. So it's in DCOM. Actually, that's something that we didn't really utilize. We didn't utilize up until Vista. We actually have some DCOM objects where we'll use those to configure, for example, the PC-to-PC sync feature. We configure the endpoints using DCOM, which makes it really easy for us to essentially take a model that we're familiar with, building COM objects, and be able to use those across a network.
Because there are a lot of, if I understand correctly, there are a lot of OLE technologies in the shell in the sense of drag and drop, the clipboard. Are those fair to say they're OLE technologies? Are they not?
Yeah, that's a good question. Those are legacy technologies, really. Certainly the shell is one of the biggest consumers of drag and drop, and then reasonably ambitious consumer of clipboard. Because ultimately those models, those functionalities based on the same model, that is the idea of representing the data in the form of a data object that either you're dragging or is present in the clipboard. There's not much like the user, the code in user and the code in LA that supports those. Doesn't get much attention because it's essentially functional and there's not much activity going on there. We certainly continue to add more clipboard formats that enable richer scenarios. So, for example, in XP, when you drag and drop things in the shell, the shell will render a cool image that represent like an alpha blended or layered window, I guess, that renders the files that you're dragging. You'll see the collection of them. They kind of fade out. And that was implemented on top of a new clipboard format that we put in the data object that enabled the source and the targets to negotiate for the information necessary to construct the image that gets dragged. And actually, we've extended that in Vista. There's a new drag and drop behavior you see, or cursors and text and things like that that come along that label, trying to inform the user about what's going to happen when they drop, copy versus move, things like that.
Do you know, you mentioned that you consider those legacy technologies. Do you figure, are you planning on for copy and paste or drag and drop? Are there other things that you're looking at, or is that basically the established mechanism for doing those operations in Windows?
One of the things with drag and drop and copy and paste is that you want to get a broad reach across applications. And at some level, there's got to be that common representation of what you're talking about. And that's going to be there. And that's pretty much going to be the data object that's in the clipboard or in your drag, that's being carried around in your drag with.
Yeah.
But there are new technologies, like .NET stuff is coming out that has, some of the Avalon work has their own drag and drop implementation and some .NET wrappers around the views of that thing to make it easier to code against. But fundamentally underlying there's still the same objects that are.
And if they were, like if you built a fancy new drag drop system or a fancy new clipboard, which lots of good ideas on how you might do it better these days. If you lost interoperability with the existing applications, if you couldn't copy and paste from Word to your new app, it wouldn't be a very satisfying solution. So I think the best strategy, because ultimately the clipboard, certainly the APIs and the kind of the model that is exposed at the lowest level is very cumbersome and difficult to deal with. But it's the perfect thing to kind of put higher level wrappers on and help our APIs around. Because ultimately the clipboard and the drag drop can tunnel any serialized data through the basic mechanism that it provides. So given that, you can essentially build any system on top of it. And that's essentially the strategy that we've taken. We've built helper objects that make it easier to participate in drag drop. Like there's an object that helps you construct or gather the information necessary to create that image that gets rendered when you drag and drop. There's helper objects for when you're getting dragged over that you can defer to that will do the rendering of the drag images and things like that. There's also helper objects for constructing the clipboard. There's new APIs for creating data objects we've exposed. Basically, our old private implementations are now publicly available, so you can create our data object, which has the ability to hook data into it and supports a bunch of stuff that makes it easier to participate in those scenarios.
So now under the covers, though, like when you do a right-click, copy-paste, or whatever, it's just a pointer to a structure, right? I mean, it's not really like some blob of data that's actually on your clipboard. They're just targeting locations, right?
Well, ultimately,
so I can't have a bloated clipboard that's actually going to affect my performance. That's what I'm asking. Yes.
Yeah. So the clipboard supports this idea of delayed rendering, which lets you defer until as late as possible the production of the serialized form of information. So, but when you do things like copy a large bitmap or an image, ultimately at some point that the bits of that image gets put into memory and then copied into another application's process space. So it is potentially memory intensive. The other trick, of course, is to use reference data as opposed to the data itself. So, for example, you select a bunch of files in the shell and say copy. Mm-hmm. We don't take the contents of those files and read them into memory and hold them there. Because obviously that would be really slow and take up way too much memory. So we refer to the items. There's data structures or clipboard formats that are reference formats. So they point to the thing that they're operating over, and it's required that the targets dereference the data when they want to work with it.
Cool. That's what I was thinking.
Yeah, definitely.
So you guys are architects, right? What do you do? Like, what does an architect do on a? So you're not an architect that actually goes and talks with customers potentially. Probably do, but you work on a product team, so you're thinking. How do you interact with developers, PMs? Like, what's your role on a product team as a title architect?
One aspect of our role is to make sure that the things that are built on our team are built the right way. So for that, we have to be reviewing the plans at a pretty broad scale across our team to make sure that this part of the system works in the same way as that part of the system, and get rid of the duplicate effort, and make sure that we're following the right sorts of programming guidelines for new extension points for reliability and robustness and things like that. So that's one aspect. What would be another one?
Well, cross team. Yeah, so we're often called upon to consult with other teams, and sometimes we proactively kind of go out and hear about things that are going on and try and make sure things that other people are building can fit in or being done in a way that enables them to fit in with our architecture. So since the Explorer is so extensible, and there's many people taking advantage of that extensibility, so we work with those people on their implementations, and oftentimes get feedback from them that drives us to do something new, add new APIs, or change our extensibility model, or adjust our plans in some way.
You also field a whole lot of questions, because you eventually you have a broad knowledge of the Windows Explorer, which is pretty big, and there are 25 different data source implementations in Windows. They're owned by a bunch of different teams, so you wind up fielding a lot of questions, and hooking the question up with the right person that can answer is another big part of our job.
Yeah. The other is just facilitating the development work that happens on our team. So there's people that are working on some feature, a developer or a program manager, they have some question, or they want to know how to do something. So we're kind of just doing consulting for them, helping them, setting them in the right direction, and sometimes writing some code for them, getting them off the right start.
So you do actually still write code?
Oh yeah, definitely. I don't work on like big individual features, but I try to keep my fingers in pretty much all of the code that's being developed. So I'll go fix bugs.
He's very successful at this.
I mean, it's difficult to do because we have a very large code base, but anything that's being actively developed, I try to pay attention to at least know what's going on there, like where we are in terms of features and being complete and things like that. But it's also what I found is you go and you see something that you don't like about a check-in, or there's some bug in it, or they could use this helper function instead of writing these 10 lines of code. I'll often just go and kind of make changes like that just to keep myself connected with the work that's going on and the people that are doing the work. So it's a great way also just to facilitate communication with developers doing the work. Say, hey, here's a change, I'd like you to review it. This relates to some code you just wrote, or here's code review feedback. Things like that. So I try to review pretty much all the code that goes into our tree.
Wow.
Do it to different levels of precision, but certainly things that I have lots of personal interest in, or work being done by new members of the team, or I want to make sure they're getting things right, or things that are really sensitive areas, like hey, there's some performance or security, or app compat sensitive piece of code. You see some major change in it, you're like, well, we better make sure that's going to work okay.
So when you were adding the new extensibility features into Windows Vista, what were the biggest challenges that you faced?
One of the first challenges we faced was kind of getting agreement on best practices for extensibility mechanisms. That turned out to be, there were just opinions all over the board, and it was a good process to go through and collect everyone's ideas and thoughts on what the right way to do it would be.
Yeah, so we have a long history of creating new extensibility mechanisms, but we didn't have any guidelines written that really informed the creation of them. And not surprisingly, we started to think about what those guidelines might be, what the best practices should be, and we kind of pulled together the requirements. We realized a lot of the defects that we had in our previous efforts. So there's lots of good examples of where we did things wrong. And sort of recognize that and trying to correct those when we can, and definitely get ourselves going in the right direction. And a lot of times, or one of the things that I've discovered is we generally assume that people know how to do things like create an extensibility point, and kind of people kind of roughly do, or a rough scale they do. But really, most developers really are not. Like if you sit down and ask them what are the issues that you should consider in order in terms of driving your the goals or the things that need to drive the design, most people really can't produce that list for you. And you start to talk to them about it, and they go, "Oh yeah, robustness, security, isolation from hangs, serviceability, and all these things." But eventually, come to people they're familiar with those, but there aren't very many experts at creating extensibility points.
What's top on your list for those issues that you were mentioning? Things do you have to keep in mind?
Robustness is kind of encompassing. The problem is when you invite somebody to write some code that's going to run in your process, you open yourself up to some huge potential problems. Most obvious ones are crashes. You've got a bug in the code, they crash, the system falls over, and users aren't happy, or your process falls over. Leaks, hangs, things like that. The ability to service those components that are running that are potentially loaded by the Explorer is one source of difficulty.
Security problems. If there are security problems, if there's some sort of file parser there, and if it's a popular one, how do you get the security fixes over to it? Would be one aspect of it, but the other aspect you have to take on as the host is manageability of those. How do you give corporate people and even end users the ability to disable something that's causing their system to go unstable? And that's a hard end user problem as well, because a lot of people do not understand what is one company's code versus another company's code versus the name of it versus the DLL, and all these subtle and important distinctions are lost on them. And coming up with a user experience that reflects that in a way that's understandable is quite tricky.
Then there's, of course, how do you make it as easy as possible for the person to write it? Because usually, the easier it is, the more likely they'll be right. So, just enabling correctness by the proper definition of the interface. And kind of classic mistakes you see people make, and we've made in the past, is making an interface overly abstract. So we say, hey, there's this interface, and here's an arbitrary set of parameters, an arbitrary set of outputs. Oh, isn't that great? It's flexible. In the future, we'll be able to add new parameters and new outputs. And it can do everything, void in, void out. We definitely have learned that's leaves for ambiguity.
It's hard to test.
Hard to test and things like that. So more and more of our accessibility points are very explicit about what behavior is expected. Trying to be good about picking the right names for things. Simplify. Avoid in-out parameters. There's several examples where we have these fancy in-out parameters, like just to reserve or to conserve an extra parameter to a method, which of course leads to huge confusion. And you read the documentation and this flag's input, this
and
flag's
security
output.
bugs. That has been the source of MSRC security bug fixes, where in-out parameter controlled the size of a buffer. It was on the way in, and on the way out it was the size required.
Yeah.
If someone reused that as to another call to the same function, you could wind up with a stack overflow. So.
Yeah, that's a good thing.
So that, and also, of course, providing implementations, stock implementations of.
Oops.
Are you back for job?
Yeah.
Job. What's our job?
Yeah. No. This the extensibility, like how to
Okay.
one of the important things for accessibility. So providing implementations in the SDK that aren't crap. In the past, in fact, still today, a lot of our SDK samples are from Windows 95 or NT4, and written COM objects written in C and things like that. Just makes it very difficult for people to grok what's going on. So we're trying to be better about producing samples and actually requiring, when we have a feature that has an extensibility point, requiring that there are implementations of both sides, there's test harnesses, design documents.
Now, are you thinking about, we recently did a video with the Windows architecture team, Rob Short and a few of his other architects, and they were talking about thinking about the release after release after the release of Vista.
Yeah.
Are you thinking actively along those lines? I mean, do you work with architects around the company and talk
Yeah.
about, okay, where do we want Windows to go?
Definitely.
What are we thinking? And without obviously getting specifics, clearly we see more managed code in Windows in the future, right? Which will solve sort of the problems you're talking about, like with how hard it is to write COM to do these things, and the untightness that can exist with these abstract interfaces that can mess things up.
Well, that can exist with managed code too. Object.
Okay.
It's like, what is it? But your question about kind of looking in the future,
Sure.
and, definitely that's part of our responsibilities. In fact, sometimes this is something we observe. Sometimes there's tension that's generated. Myself and Mike, and we try to represent the requirements in the long run, which sometimes requirements for the future. So we're doing some work, have a feature. Somebody wants to, hey, this is the feature they want to get it in, and they're thinking, if you think solely about this release, it might make you to make the wrong trade-offs in terms of, if you're considering a longer-term release, like there's the supportability cost of any new feature or an extensor point, for example. There's some high cost that comes with those, and we try to represent the future in a lot of the discussions when it comes to, is this the right thing to do? What's the best way to implement a feature, or what's the best trade-off of how something should work? And the guys, Rushford, these guys, we work with them a lot. So, in fact, kind of part of our responsibility is to be in this network of people. We know those guys, they know us, they have issues with our stuff, they come to me, and vice versa. So, having a good relationship with those guys is really important for Windows as a whole, because kind of communication is fundamental difficulty that we have. Having people communicate about what they're doing.
Sure.
It's like the biggest constraint really on.
And changes, changes that are being made in components over here will affect people over here, and there's the whole notion of needing to be more componentized, so that you guys can just rock out on the shell and not have to worry about what they're doing on the kernel.
Yeah,
To some degree. I mean, that's going to be an interesting development.
We've made some progress on that. That's definitely been that's one of the things that's been new in this release of Windows. That is, there's this serious effort behind defining components and the boundaries of those and the relationships between them. You've probably heard about the layer map and seen these diagrams, and trying to provide some structure to the way Windows is put together in terms of layering. Layering of components, things like that. And we definitely have we are responsible for a number of components that don't fit in well to that diagram. We recognize that, and we have plans and have made some progress in Vista towards untangling some of these messes of dependencies that exist. So it's definitely an interesting topic. Yeah.
What would you say to developers who want to do a shell extension in managed code?
That's a great question. Unfortunately, at this point in time, writing extensions to the Explorer, or actually any native process for that matter, is in managed code produces enough difficulty that we can't recommend it. Mm-hmm. Certainly, it can be done. It has been done. There are a number of managed code implemented extensibility or extensions that people have written for the shell. But there are reasonably complicated set of problems that come.
It's really not just managed code. It's if you're developing in a language that has some single version per process runtime component, and you're extending some host, this process that you don't control. That's where this problem comes in, and that's why the CLR in managed code .NET has a problem fitting into Windows Explorer. It just happens to fall in this class of code with runtime components that are process-wide. You wind up with versioning problems, and if you have two extensions that each require a different version of the CLR, one of them is not going to work. Mm-hmm. They're each hard-bound to their extension. And something as important to the end user is their Explorer that they go to browse their file system and launch their documents from. If that fails to load because of some CLR management versioning conflict, that's a bad and really bad end user experience.
So it could be something as kind of silly as a thumbnail handler. That's where maybe the user didn't care to see the thumbnails, or just they're looking for a Word document. There happened to be a file there that happened to invoke that handler. So it's unfortunate that this is a situation, but at least I guess the good side is that there's been, well, this has produced lots of healthy discussion within the company, and there's actually very good guidance kind of coming from the CLR team these days on this topic, and they have a really good description of the issues, and I think this was actually discussed at the PDC, and there's actually a white paper or something that's being written on this topic, but guys like Jim Miller of the CLR team are kind of on point for this issue. So I don't like to be the deliverer of that information, like don't write a shell extension. So I'm pointing to Jim these days.
Okay. Do extensions get loaded into, say, the common file dialogues?
Yeah,
third-party?
that was a classic example. So in fact, here was a great case. So you have a CLR 1.0 app that uses the file open dialog, and then it tries to load a CLR 2 component that requires CLR 2. What do? Well, you can't load it. Which
So the file open dialog doesn't work.
yeah.
So let's talk about
a pretty
that.
common piece of code. That's something you use pretty commonly.
Yeah.
I mean, theoretically, why can't you load it? I mean, why can't CLR 2.0 run in a separate process? I don't understand that. So you just spin another thread.
So
Can you explain the problem?
You can mitigate the problem here is with in-process extensibility.
Okay,
So
in-process.
the file open dialog is an in-process extensibility point.
Okay.
So you can mitigate or avoid the problem by using out of process, running this out of process. In fact, we're aware of people that are doing that. That is, they've got COM or managed code based APIs, and they're proxying those into the Explorer process via some native code. So they've got kind of a shim that runs in the Explorer process and can do kind of improc stuff, and then it can talk to an out-of-process component. So it is possible to build a solution that completely avoids the problem and implements or gives you a managed code implementation, but it's definitely not trivial. It requires a lot of understanding of that interop layer. So you can imagine some extensibility points are reasonably trivial, like our thumbnail handler extensions. We give them the stream of bits that for the file that we want a thumbnail for, and they hand back a file, so an input parameter, an output parameter. That's the kind of thing you can imagine. Oh, well, you can marshal that over to another process trivially. Do your work there.
Though performance-wise, you may not want to. Extracting an icon or a thumbnail.
Yeah, sure. But so we recognize that this is that produces tension for a lot of our customers. Certainly, the vast majority of developers, numbers-wise, are writing managed code. And we recognize that. So we hope over time there'll be more layers written on top of our APIs to make them more appropriate for managed code developers. In the future, we'll be producing some of those ourselves. Kind of in the near term, we hope that the framework guys kind of can take on some of that stuff. We've been talking to them about some of these things. And then, of course, there are solutions that people can build themselves using interop tools that the system supports. Obviously, those aren't the best way to go.
It sounds like some good job opportunities for native C++ and COM developers in the near future.
Definitely.
So,
Yeah, I mean, our team is C++. We're doing all C++ development. We have some people with some managed code experience, but we do. I feel like we do pretty well productivity-wise, and kind of have appropriate set of tools with C++. I think it works well for us. Is appropriate. So certainly there's great things that come with the managed programming environments, but C++ actually does pretty good for us.
So I'm dying to ask you this, having been on the Shell team for so many years and having seen this process, how much of this, say, Windows 3.0 is in, how much of that code base is actually in Windows Vista?
Less and less every release.
Yeah, there definitely is some. Like we have this there's still, I think we still have groupconf.exe. So
It does a lot less than it used to.
yeah, we've been ripping code out of that. Like we dumped File Manager in Windows XP.
Frogman.exe.
Yeah. And I'm not sure who wrote File Manager, but that was a brilliant piece of code. Yeah, there's lots of lots of things that are getting tossed, and we've been, I think we've been more aggressive in the past 4 or 5 years maybe, getting rid of stuff. And kind of for the longest time for a while we were like, okay, there's the stuff, it's sitting there, nobody uses the feature, no big deal. But when you start getting security attacks coming through some legacy component that's sitting there that no end user uses, you start to question, like, why do we have these 10,000 lines of code for this feature that nobody, as far as we're aware, uses, and it can be used as a security exploit. And let's get rid of this component. And it's harder than it seems, actually, to decide, hey, this thing isn't being used, or its usage can be replaced, or nobody will care if we remove this feature. But it definitely is beneficial, security and kind of surface area wise. You can get rid of stuff that you don't need to support. It's definitely a way.
So what are some of the new main constructs of the Vista shell? So when we talk about the Vista shell, what are some new things? I mean, you have these beautiful new clear UI and all these things that were probably challenging to implement.
Yeah.
So is DirectX kind of built in? Are you using that natively in the shell now? And what kind of major architectural changes can we see?
Well, kind of in the topic of what is the shell? So part of the shell is a UI framework, mostly for our own use. Really, there's kind of more and more things like WinForms and Avalon, things like that, or the things that people use for UI frameworks. But we have our own UI frameworks, much of which is public, in the form of things like the common controls, list view, tree view, and wizards and property pages, and new APIs like task dialogues, and this now Arrow Wizard. Themes is a big important part of our UI framework. That is providing the resources and the metrics that are used to describe how to render a button, or how to draw a list, how to draw a list, parts of the list view, or how to draw the slider control, or things like that. So we have improved a lot, and made publicly available a lot of the theme parts that in the past have been private. Those theme definitions now essentially prescribe a spec for the way a control should look and behave, because it includes things like hover states and focus states and things like that. There's also kind of low-level APIs for rendering using double buffering to get the right effects. Because one of so back to your question about DX, the shell itself doesn't program to DX. The window manager, the desktop window manager, is the thing that programs the DX layer,
Okay.
and our layer essentially programs bitmaps. So we draw into buffers that the window manager takes and composes using DX, getting the transparency and the animations and the effects that you see there. So the thing that was difficult for us was making it so that all of our rendering code paths can render in a way that preserves alpha, because in the bitmap formats there's the RGB and then the alpha channel in the bitmap information, and preserving that alpha information. The GDI APIs or most of the GDI APIs don't preserve alpha. Is one of the problems we struggled with. So we had to build a collection of APIs that helped us manage that difficulty and made it possible to let our controls and the different UI pieces render in ways that enabled us to get the glass effects in different places. So you see glass effect at the top of the Explorer, like the address bar and the search form and things like that. And you'll see a media player, the glass at the bottom, and the photo previewer app also has glass at the bottom. So it's possible to write code that does that right. You have to take some care depending on the rendering APIs you're using, but it is possible. So there's kind of lots of small innovations in this space for Vista. In the end, though, I think they're actually pretty significant. The theming additions to the theming architecture, I think, are very significant, because those essentially prescribe to set a spec for the behavior of certain controls, or the appearance of behavior controls. And that enables people to take our theme parts and build using their own framework, whatever it might be, to get the same look and get the same experience across application. Certainly there's lots of different UI frameworks that are in use in different web forms, things like Avalon, and lots of applications build their own. So.
Excellent.
So any last words for developers who want to get started with shell programming, who may not have been around since Windows 95 and have sort of gathered this knowledge throughout the years?
We are working on getting MSDN, a little bit
Yeah.
better coverage over the introduction to the shell and what it is and
What the extensibility points are and how to use them. So
that would be one reference.
Yeah, I'd say taking a look at the new APIs in Vista, from the new COM interface to the file open dialog, controls like the Explorer browser control that lets you host the Explorer window in your application, the namespace tree control that lets you get the Explorer tree, put that in an application or wherever you want. Take a look at all the stuff that's new, because I think that reflects directly on kind of the things that we think are important, and I think tries to manifest kind of some of the design initiatives and the kind of better programmability, easier programmability, and more robust stuff that we were talking about earlier. So, maybe difficult to diff our header files, but you can search for new stuff in SDK and take a look at that, because there's definitely lots of cool stuff. It'll kind of get you going on what's new and important.
Excellent.
Thanks so much.
Thank
you, guys.
Very excited to work with the user shell, the Windows shell, actually.
Absolutely.
That's great.
Thank you, guys. Good luck.
Thanks.